Welcome to the Crazy Hat Chemist. So today we're doing another video in atomic structure and electron configuration. So let's get started. Bam! Today we're going to do the electron configuration, orbital box diagram, and a set of quantum numbers for lead. Okay, that's atomic number, a Z of 82. Get the lead out, baby! Yeah! So, you're going to find the noble gas that is prior to 82, and that would be xenon. We have done this before, actually, using xenon many times. So, xenon in brackets, 6s2, 5d10, 4f14, 6p2. This is a noble gas notation. Of course, I've mentioned this a number of different times, but I'm mentioning it sporadically every now and then in the videos. So, what we're going to do is we're going to get the electron configuration. We got the electron configuration. We're going to get the orbital box diagram of the same thing. Now, I've written this according to the order of filling, and that is the lowest principal quantum number interior, that is the 4, then next lowest principal quantum number, 5, then the highest principal quantum number, 6. And I put the 6's together, the 6s, 2, and the 6p, 2. I want you to look at your periodic table and see where lead is and find out what group it is in, and then figure out how many valence electrons should lead have. Okay? And you should be adding up the largest principal quantum number, S and P, summing them up. Okay? So either way you do this, either the top electron configuration or the bottom one. The bottom one gives you a good representation of the order of filling, and then you should be able to get these valence electrons or the valence electrons from your periodic table. Both of them will give you the same answer. I'm going to come up with that answer in just a little bit, but we're going to do a little bit more. I already mentioned that this is the energy level of filling. Here, we're going to do the orbital box diagram. So I'm going to fill in these electrons as is appropriate according to their numbers as we come up to them on the periodic table. So 6s, 1 and 2, and then there's a 5d. I place 1 in there. Then after that 5d, then I have to go to the 4f's and filling in all the 4f's. Notice that I've filled in 7, that is half filled 4f's first, and then I start backfilling them like this. Okay, now all the 4f's are now completely filled. Now I go back to the d's and I fill in the d's as appropriate. Again, I have up arrows half filled first before I start backfilling them. And now we're backfilling them. Hopefully that makes sense. Now I'm still not done because I got that 6p to deal with. And I got a 6p1 and a 6p2. Okay, so that is the orbital box diagram for lead. Okay, that corresponds to the top electron configuration of which we drew. You could have drawn out the orbital box diagram of the bottom one of the energy level filling. That would be perfectly fine. Remember, we came to the valence electrons, okay, and hopefully you got that. This is paramagnetic because there are 2 unpaired electrons in lead, and that's in that 6p. Okay, 2 unpaired electrons, and that's in that 6p. Okay, we already did the valence electrons, and that is 4. Now I'm finally giving it to you, but it is in group 14 or 4A on your periodic table, depending on which kind of periodic table you're using. You are adding up the largest principal quantum number, that's a 6, S and P of that, and that's 2 plus 2, that gives me 4. Okay, all right. And then we're going to get a set of quantum numbers, that's 4 quantum numbers, for which electron? The last electron. So this time what I want you to do is look at your periodic table and figure out what the set of quantum numbers are for that particular lead. Or you can look at that orbital box diagram, one or the other. So the n is the n value, and that's a 6. So the n is 6 because it's a 6p. Okay, and then the L value is the type of orbital. So it's a p-type orbital. Remember, s's are 0, p's are 1, d's are 2, f's are 3. So this is an L value of 1. Okay, now what box is it in? It's in the middle box. The middle box is always a 0. To the left of that is a -1. To the right of the 0 is a +1. But it's in box 0. It's in the middle box. So the m sub L value, the orientation along the 3D axis, is a m sub L of 0. It's an upwards facing arrow. That's to heaven. That's positive, and therefore that's a m sub S value of +1/2. And there are those values right there for you. So n of 6, L of 1, m sub l of 0 and m sub s of positive 1/2. Hopefully that worked for you. That is lead 82. That's a very important electron configuration because you're combining the largest quantum number to get those valence electrons, and hopefully you see that in those electron configurations, whether you write it the original way by following the order or you follow the energy level. Okay, that was another crazy hat video, and here is most certainly a crazy hat. I'm not really sure if this is a fictitious creature or if it is a real creature. It might be like a snipe, and you can't even find it. I don't know. Give me a thumbs up if you like that video. Maybe give me a thumbs up just because you like the crazy hat. I don't really know. Subscribe to my YouTube channel, and I will see you next time for more cool chemistry videos. See you later. Bye now.